I'm looking into optimizing user engagement in highly automated virtual assistant to enhance energy management and consumption. So my object of inquiry is the virtual assistant. Know what it is, what it might become in the near future. So what we can see is an increase from 67 million to 120 million in 1 year. It is predicted to raise more than 300 million by 2022. The number of users, because it's part of your mobile, is going to increase from 1 billion to almost 2 billion in the next 3 years. So the virtual assistant is going to be the platform to manage energy in the present and in the future. So we have currently 90,000 skills, which is the application. We have like Home and Nest and all the big companies moving into the energy sector. Well, we can see this is Duplex. I don't know if you've seen this video. It's a system that can make appointments on your behalf. So what we are seeing is a mutation in the system from reactive, Alexa play a song, to the system become proactive and doing something on your behalf in the background. So, but there is a fundamental problem. This is a statement for DeepMind, which is the most advanced artificial intelligence company in the world. No amount of testing can formally guarantee that the system will behave as we want. So that presents a fundamental challenge as we move into sustainability and the impact of this sustainability. So we move into automation. Until 2018, the fundamental paradigm was human-machine, which implies that the human is superior to the system, and this is about designing ability, integrity, and benevolence. But at the end of 2018, we have from DeepMind presenting a framework which is about machine-human, where they have absolutely clear that the machine is going to be superior to us. So it's about designing robustness, assurance, and specification. However, there are two problems, which is interpretability and interruptibility. The machine doesn't know what it's doing, therefore it doesn't know when it has to stop. So we are a long way there. So in the meantime, we are using kind of a human-human interaction paradigm, which is about designing autonomy, accountability, and reparation. It's about relational design, designing relationships, and these relationships is all based on trust. So what we try to do is build a calibration system, which is the tension between predictability and persuasion. The system wants to capitalize because it's a business-led system, and the user wants protection. So I think is how do we design this? So what we are using as a technique is autonomy levels. It was introduced in 1978. It's the main tool. This is a debate where it's a simplification of reality, but at the same time, everyone understands. So it can address a lot of stakeholders. But again, there is the fundamental problem. We cannot guarantee that it's going to behave as we want. So what do we do? So literature is showing from the end of 2018, the integration of apology as part to keep the user engaged, because if the system fails 30%, the user is out. What we are integrating is a new level, which is compensation, because as the virtual assistant is going to become your doctor, your financial advisor, your energy advisor, then highly sensitive areas become in the process. But then the question is, okay, if something goes wrong, who is accountable? Who has to deliver that apology, or has to deliver that compensation? So we generated this kind of triangulation. So we ran a survey. We built 8 case studies to ask people what they think. This is the results. 50%, no matter what, they say that the user is accountable, whatever happens. But then we have 51% that says, no, we want some kind of reparation. So if you don't integrate that, you lose 50% of your users. And then in terms of accountability, 54% demand, or the accountability is in the system, is the algorithm or the designer or the platform that they want to get that reparation. Then in user engagement, we have 3 challenges: asymmetries, dependencies, and inferences. So in terms of asymmetries, is kind of data, which you were touching, which is what kind of data do we need, and then from the past and then from the present, that we had access to the microphone and GPS and sensors. It's kind of, then we have, then is inferences, which is what kind of knowledge do we extract from the data. Today, there is absolutely no regulation on that. No law can protect you against that. And this is the information that you take by which the system makes decisions. And then we have context. How does it impact? So when we touch these four highly sensitive areas, then users get very nervous. And then we have kind of a range of actions that can, from a happy services to kind of end in death. So with this, we build a system with three fundamental levels. We have access, and then we have inferences, and then we have reasoning with 5 different variables into that. And then we build a matrix where we can map the score against this Cartesian model, and then we can understand what will be the risk on that. Then we try to map the energy management and consumption. So we run some workshops at the Royal College of Art. So we map the present model, and then we start to extrapolate how that might evolve into the future. So what we got, interestingly, for example, money. People, they don't care, is the least important thing, which is interesting after 2 days listening about costs. They are very concerned of how it's going to impact in health and well-being. So we have, there is a kind of a mutation. So right now it's about optimizing health and well-being. In the future it's about the impact of that. Now it's about managing information. The future is about managing behavior. The present is about monitoring behavior. The future is about monitoring dependency. The present is about protecting money, and the future is about outsourcing. So you are going to have a system that is going to be making the deals on your behalf. So that was very unexpected. The smart fridge become kind of a fundamental object. So we have the agency and the things related to food. What do we eat, what do we cook, and the calories that we eat, and then the impact on the environment, kind of the deliveries of that, the energy consumption, the room temperature. That was unexpected. And then we have two wicked problems when we design this system. One is access, how much? Do we need a lot of information to get the right decision, but then it can lead to manipulation? It is an unsupervised system. It's very tricky. And then the intentionality. Who are we protecting? Are we protecting the user? Are we protecting the environment? Or are we protecting the business? When we have something which implies an overlapping of them, we have to make a decision, and that has consequences in the future. So we have built like a calculator. Can you click into that? So can you go to preview? So with that, we have kind of widget, and this is out there, so you can go there, and then you can select what kind of access do you need, what kind of monitoring do you need, and then you have one level, which is the access. Then you have another level, which is the inferences, where you can select what kind of algorithmics you need to implement. Then you have the level of autonomy, where you can place. For example, if you are designing a system to manage your information, maybe you can go like the system makes the decision, but then it needs you to approve. Then we move into the level of reparation. So in this case, it could be, for example, a low compensation. If you go lower to the levels of accountability, then if something goes wrong, it's going to be the company. Then we have another level, which is the context. In this case, would be money-related activities. Then if we go, we can define what would be the impact, and then we get a score. So we can simulate more or less how it's going to be that interaction. And then we can map, in this case, would be kind of medium going to high risk. So maybe we need to tie some of the parameters. But we can envision that a priori. Would it be possible to go back to the... You can close it if you want. Maybe with the 3 fingers, slap it down. No, doesn't want to go. You move with the fingers. You move the 3 fingers. So while we look into the future, so the design interventions that we implemented, first we implemented a posteriori, generating the scales of reparation and accountability. Then we generate a calculator, and now the future is generating a self-calibrator algorithm, so it's inside of the system. With this, it's about moving into ethical computing. We call this synthetic consequential reasoning. It's about integrating a sense of consequences on algorithmic reasoning, kind of a synthetic morality. And in the way that we see this, the Royal College of Art, so design is a future-led activity, which is about perspective and transformational. It's about potentialities. And we look at this as a way of build preparedness, readiness, and appropriateness to the built environment. So by mixing design with science and with technology and with sociology, we can achieve probably a better society. So thank you.
Thank you very much. You've got quite a little bit of time left, so we could have slowed
So
down a little bit.
like
But it looks very interesting. Who has got some questions? Yeah.
How do you measure sensitivity or sensibility?
What we try to find out is what are the highly sensitive areas. So areas where people get very concerned. So we run some workshops, and then we build like some surveys, and we saw that when you touch money, when you touch health, when you touch privacy, people get really concerned. And then what you have is an increase of people willing to leave the system if something goes wrong. So then you need to integrate some kind of counterbalance mechanism. So that's why we needed to integrate reparation and then accountability, because this is something is missing. Now if something happened, they are not liable. What we want to integrate is this sense of accountability inside of the system. It's really interesting after you, because you look from the user perspective, but in the way, by projecting a little bit into the future, you can see that the interaction will be moving to the system. And then what we need to find out is the scoring of the system, actually, in order to understand that, because you are going to rely on the system making things on your behalf, whether it's the deal, whether it's deciding what is the temperature, what is the food that you're going to eat, whether you are on diet, that is going to be connected with your doctor, then it's going to be connected to your fridge, and then it's the impact of all these decisions.
So can I ask you, the survey that you did, what sort of sample size were you looking at when you started to test some of these ideas?
We did like small samples, but well distributed. So we are looking like 50 people from 16 different countries, ranging from 18 to 67 years. Mm-hmm. So to get a sense of what they think when we develop a range of case studies of how these technologies might impact. And with that system, then we start to weight all the variables into the system. What we need is to increase that sample and then fine-tune the model, and then we can build kind of a self-calibrating algorithm. So we can put the system inside. Right now it's a tool where you can model things. For example, for computer scientists, they don't have the sociological aspect when they decide. So by going through the calculator, you get, I'm going to have an impact here, I'm going to have an impact there. So right now, it's at this stage, the idea is to build a system that can be inside of the virtual assistant.
Does anyone else have questions? Yeah.
Actually, I'm an engineer. I'm not in this area, but I just want to learn that what's your definition of design research?
Yeah, we are having a big debate at the Royal College of Art on that.
Is that
because we are making the transition, but in the way that we are positioned, this is a future-led activity which involves deductive and abductive reasoning, so that allows us to go one step further, which, for example, research in engineering is limited by the present. By being able to access that near future, we can start to see the impact of these technologies. So we can, by combining design with engineering or with science, getting the present and a little bit into the future, probably we can design better systems.
Follow-up question is what type of training do you need to actually to do a good job in design research area?
I think you need to combine. So for example, in my case, I did cognitive computing, I did neuroscience, but then I did from a biological perspective in a sociological university, which is fundamentally a radical thinking. So when you start to mix all this, it's very interesting, but then you need to define what is the commonality in all these things. And that is the challenge that we are having now at the RCA. How do we define that commonality? So right now it's about preparedness, something that is appropriate. So that kind of connects science and design and technology and all this. But we are putting like 3 papers on that, defining the ontology, defining kind of a new ground, which called the transformational sciences, and then building on top of that. But it's everything in the process right now. So hopefully in the next year we can see something.
Thank you, Fernando. Thank you for the question. I'm Stephen Wang. I'm the supervisor of this project. I just want to simply articulate as part of the answer. There's tiny differences between design research with research in the design field. So this is a typical type of research in the design field because it's involving human factors and focus on the interactions with the AI system and with a clear goal to achieve higher sustainability. Design research is more focused on the design methodologies and which contributing to the future of design approach, which is quite different. So, sorry, I think just articulate this. Yeah.
Yep. Okay. Thank you.
Is there any more questions? Yeah.
Can you explain more about how do you calculate the sensitivity of the parameters?
Pardon?
How do you calculate the sensitivity of the parameter? Can you?
So what we did is that we ran like a sample and workshops and try to map how this might develop and where people get concerned. So with that, we define the fundamental variables of the impact thing, and then we play with the scales. Some of them need more weight, the accountability and all these things, and then the automation is fundamental. The idea of the system is that it balances. So the more automation, the more impact. So that's the fundamental foundation, and then the areas affecting that, putting on context of this.
Okay. It's a really interesting study. In Australia, I know a friend who's got one of these things, and she said when people come to visit, they say, "Can you please turn it off?" That's how paranoid they are. So this issue of trust, and it's also interesting the idea of cost. That it didn't come up, and you wonder. I'm very interested to think more about why that is, because what we see playing out, say in Australia, is that it's the #1 issue.
Right now, in the present, is
So I'd be interested to follow up with you in this, and also who funds this research. There's some really interesting questions. So thank you very much, and I'd love to follow up. But we've